So we will be learning about practical problems on union and intersection of two sets. If you haven't seen my previous videos, you can watch them by clicking the link given in the description and the I button. So first, let A and B are two finite sets. Okay, we are considering A and B as two finite sets. Let us draw the Venn diagram. Here is the universal set U, and in here we can draw the set A. This is the set A, and let us consider the set B. This is the set B. Okay, so in here you can see this is A minus B, this portion, only this portion. This is A intersection B, and this is B minus A. So from here, from the diagram, we can say that A minus B, comma A intersection B, and B minus A are disjoint. Okay, they are disjoint sets, and also their union is A union B. A union B is the union of all these three sets. Okay, so we can write number of elements in A union B. Number of elements in A union B will be like n of A minus B. Okay, A union B means the whole portion. The total portion is A union B. So number of elements in A union B will be n number of elements in A minus B, and number of elements in A intersection B, and number of elements in n B minus A. Okay, so we are writing like this, plus n of A intersection B, and this is n of B minus A. We are adding n A intersection B and subtracting the same. So if you can watch closely, this portion, the number of elements in A minus B and A intersection B, A minus B and A intersection B, they combine to the set A. So this will be A, and this portion B minus A and A intersection B will be number of elements in the set B, B minus A and A intersection B. If we add those number of elements, we can get the number of elements of the finite set B minus A intersection B. So this is the basic formula for A number of elements in A union B. If there is a case if A and B are disjoint. Suppose these two sets are disjoint. So what we will get? We will get A intersection B will be phi, the null set. So in A intersection B will be 0. So in that case, if A and B are disjoint, we will omit this element. Okay, in that case it will be like NA union B is equal to NA plus NB. That's all. Now if A, B, C are three finite sets, then we can write n of A union B union C is equal to n of A plus n of B plus n of C minus n A intersection B minus A B, we can write B intersection C minus n of A intersection C plus n of A intersection B intersection C. This is the formula which can be proved easily using the previous formula, and we are not wasting time proving this. You can find it on Google. So let us do a problem from the exercise 1.6, question number 8. In a committee, 50 speak French, 20 speak Spanish, and 10 speak both Spanish and French. How many speak at least one of these two languages? So let F be the set of people who speak French, and S be the set of people who speak Spanish. So n of F, number of people who speak French, is 50, it's given, and n of S is number of people who speak Spanish is 20, and n of F intersection S, that is number of people who speak both Spanish and French, is 10. So we have to determine how many speak at least one of these two languages. That is the union set. That is the union set means if union S, n of f union S we have to calculate. So the formula is n of f plus n of S minus n of f intersection S. The first formula we discussed today, and n of f is given 50, n of S is given 20, and n of f intersection S is 10. So the answer is 60. So 60 speak at least one of these two languages. At least one of these is union. You have to understand that if says at least one of these two languages, at least one of these two, then we have to determine the union. And if says both and using the symbol and, if we consider or, then we will have to use union, and if we have to determine and, then we have to consider the intersection. So we are going to solve the next problem. It is actually the previous problem of the exercise. In a group of 70 people, 37 like coffee, 52 like tea, and each person likes at least one of two drinks. How many people like both coffee and tea? So let C be the set of people who like coffee, and T be the set of people who like tea. So what is the difference between the previous problem and this problem? Here we have to find how many people like both coffee and tea, and in the previous problem we have to find at least one. Here given at least one, and in the previous problem we have to find at least one. So you have to remember that there is given, you can understand if I write down this, n of C is 37, n of T number of people who like tea is 52, and given that at least one of two drinks, that means this is the union set. At least one means union. So n of C union T is given 70. Okay. So what we have to find, like both coffee and tea. Here given and means always intersection. So applying the formula, C union T is equal to n of C plus n of T minus n of C intersection T. Okay. So it is given, union is given 70, n of C is 37, it is 52, and n of C union intersection T we have to find out. So n of C intersection T is 70 minus, was that 89, I think it's actually 89 minus 70, that is the answer is 19. So 19 people like both coffee and tea. So this is the last problem we are doing today. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? How many like tennis? So first let T be the set of people who like tennis. Okay. And C be the set of people who like cricket. Given, what is given? N of T union C is 65. It is given group of 65 people, it's 65, and 40 like cricket, that is N of C is equal to 40. 10 like both cricket and tennis, and it's written and means that will be intersection, that is T intersection C is 10. So how many like tennis only and not cricket? How many like tennis? So let us find out first how many like tennis. We have to find N of T. Okay, is question mark. So as per the formula, N of T union C is N of T plus N of C minus N of T intersection C. So it's given 65, N of T plus N of C is given 40, and N of T intersection C is 10. So the value will be N of T is equal to 65 minus 40, that is 25, plus 10, that is 35. So that is the number of people who like tennis. So apart from that, we are erasing this. We have to find out how many like tennis only but not cricket. So that will be the set is the set will be like T minus C. tennis only, not cricket, that will be t minus c, n of t minus c. If we represent it in Venn diagram, if this is the Venn diagram, this is what this is t and this is the set c. Okay, so t minus c will be, you can you have to understand, t minus c will be this portion, only this portion. This portion is the t minus c. So t minus c means, you can let us consider from there, t minus c means n of t plus n of c, sorry, n of t minus n of t intersection c. We have to eliminate t intersection c from n of t. This is from the Venn diagram. N of t we get from there is 35. We recently measured the value as 35, and n of t intersection c is given 10. So answer will be 25. So we can try in another way to calculate how many like tennis only, not cricket. Let us consider two sets again, t minus c and t intersection c. One is t minus c and another is t intersection c. So we have to calculate n of t minus c. Okay, so how you will calculate? First of all, you see these two sets are disjoint. So disjoint means t minus c intersection t intersection c will be 5. Okay, so if we take union of this, that is t minus c union t intersection c, it will be t. You can see t intersection c and the t minus c's union will be the whole t. Okay, so this will be n of t is equal to n of t minus c plus n of t intersection c. Okay, and there is a set that is n of t minus c intersection t intersection c. This will be neglected. Why? Because the intersection of these two sets are 5, so this will be 0. So we have to calculate only this. N of t we got 35, n of t minus c we have to calculate, and given n of t intersection c is 10. So n of t minus c's value will be 35 minus 10 is 25. This is another method you can use without using Venn diagram to solve this problem.